Syntax graphs. These are the syntax graphs for control statements in different languages. By using the syntax graphs, user can identify terminals and non-terminals for specific grammar. These syntax graphs are helpful for the user to identify the correct grammar of those loops. Let's move to C++ language. This is the syntax graph for if condition. The syntax graph for switch case in C++. Do while loop. While loop. For loop. This is the syntax graph for if condition in language C. Switch case. This is the do while loop in C. This syntax graph shows while loop in C. For loop in C. This is the syntax graph for Python if condition. Switch case in Python. This is the syntax graph for the for loop in Pascal. While loop. This is the syntax graph for the if condition in Fortran. The Fortran repeat until loop. The Fortran while do.
Let's move on to the internal execution of a computer program. Irrespective of the programming language we use, after the compilation of the source code, it is converted into a machine code. We know that the computers we are using today are developed on von Neumann architecture. There are three main types of instructions: fetch, decode, and execute. Let's take a Java for loop example and trace the execution in CPU and memory. In the for loop, first step is create an integer type variable I and store number 0 in that variable. After a successful variable declaration, the memory should be like this. This slide represents the architecture of main memory and CPU. CPU consists of several parts: ALU, control unit, and registers. Registers are special purpose fast storage locations in CPU. Here you can see there are two registers, MAR and MDR registers, that is memory data register and memory access register. The ALU, arithmetic and logic unit, carries out arithmetic and logical operations. The accumulator is used to identify registers. Let's go and see what these MDR and MAR registers do. MAR contains the memory address of the current memory location being accessed by the CPU. The two operations on data are reading and writing. Memory data register contains the data that was read or that is going to be written in the memory. Let's go back to our example. We wanted to store number 0 in a variable called I. So number 0 is stored in the accumulator first. Then the MAR register stores a variable name, that is the address of a memory location. That address A108 is from the main memory. Using A108 we can address a memory location in the main memory. Then the number 0 is stored in the MDR register. The next step is MAR register select the current location, that is A108 from main memory. Then MDR register store number 0 in A108 location. Now we have successfully created a integer type variable I, and that address is A108, and we have stored number 0 in that variable. Next, what we have to do is the condition checking part. We have to check whether the ith value is less than 10. When the ith value is less than 10, we can proceed. Otherwise, we have to terminate the for loop. This is done inside the ALU. Let's move on to the next part, that is incrementation. That is I++. We have to increment ith value by 1. Here we have described there are two more registers, that is CIR and SCR registers. CIR is the current instruction register. SCR is the sequence control register. The sequence control register contains the address of the next instruction to be performed. The CIR current instruction register contains the current instruction being executed. Let's move back to incrementation. The SCR register contains the next instruction to be performed. Then the MAR register is updated with the address of the next instruction to be performed.